little bit different than with the arithmetic. What makes a geometric sequence different from an arithmetic sequence? Victoria? So we have repeated multiplication. Again, it's that repeated multiplication division, and we call that the common ratio. It's the ratio by which everything's being multiplied. And we represent that with the letter R. The common ratio is the value by which everything's being multiplied. I want to show you guys a little bit of something here before we actually get into, before we get in too much into this. We'll come back to this problem here in a minute. Let's suppose I had 3. We'll start off with a sub 1 being 3. And my R is 2. So I'm multiplying by 2 every single time, right? Alright, so a sub 1 is 3. What is a sub 2? Six. Or just 3 times 2, right? So what is a sub 3? Okay, and how'd you get that?
Times a sub 2 by 2.
So 3 times 2 times 2, right? So what's a sub 4? So 3 times 2 times 2 times 2. A sub 5. 3 times 2 times 2 times 2 times 2. So what do you notice in this? In terms of the number of 2's that we have versus the term number? Caitlin?
There's 1 less 2 than there is the term number.
Here we go. So we're multiplying by 1 less 2 than our term number, right? And if we represent 2's not just as the number 2, but rather as the letter R, for the common ratio, then what we have is 3 times R. 3 times R, which actually gives us 3R squared. So this would be 3R cubed, 3R to the 4th. So then how would I represent a sub n? Chris?
3R to that power.
No. Because remember, each one of these is 1 less than a term. So R to the n minus 1. So what we actually just did here is we actually came up with the explicit formula. And that's how we actually get our explicit and our recursive formulas. I'm going to give you guys a minute to copy that down. Okay, so here we go. Write a recursive and explicit formula for each sequence. So if we look at a sub, or the first one here, we have a sub 1 equals 5, and R equals negative 3. So how would I find the a sub, let's do a recursive. Let's do our recursive. So a sub n, again, we're up here, we're using this model. So what's my first term? Or what goes in there first? We'll say a sub n minus 1. And what are we doing with that? Multiplying that by what? Multiplying by negative 3, and we're done. That's kind of nice for the recursive. If we're over here, we're doing recursive. That would just be negative 20 times sub n minus 1, so we're multiplying by negative 20 every time. Now let's focus on the explicit. So Matt, how would I write my explicit formula for that blue problem?
5.
Okay,
And parentheses, you have -3 and
there we go. So 5 times negative 3 to the n minus 1. Okay, let's try the next one here. For this next one, okay, Brian, we'll put you on the spot. What do you think? Again, use the top one as your model.
I think AN equals
Alright.
100, parentheses, negative 20, n minus 1.
Easy stuff, right? Okay, the bottom two. Find the next 5 terms of the geometric sequence. Okay, so we start off with a sub 1. It's 5. How do I find a sub 2? Lucas?
Multiplied by negative 3.
So what does that give me? So Alyssa, what is negative 3?
Will the following students please report to the office? Tommy Colbart, Megan Davis, Kyra Cole, Bailey Sutton, Allie Purdy, Makaira Coble.
Alright, so Alyssa, we had negative 15 as term 2. What's term 3?
45.
Should be 45. Brady, what's term 4? Say again, a little bit louder. Not 90, we're multiplying by negative 3. Positive. Negative 3. Very good. Alright. So I don't think we really need to go over here and do that one. Alright, I think we're getting this idea of what we need to do, right? We've got our explicit formulas and we've got our recursive formulas to define the values of the sequence. Okay, so that's all we have for our notes today.